All right. Hi. Hello. Happy day. So here we are continuing algebra lesson 7-9, exponential versus linear relationships. So we introduced our new vocab, common difference and common ratio, which we're going to try and use in these examples. Example 1, determine which table is linear, which is exponential, and then create equations for each. Okay, so first thing you always want to take a look at is starting with those inputs or those x values. And here, little test of your vocab, that's what they're trying to do here by using X and Y versus input and output. They're looking to see that you know that Y is the output and X is an input. So first thing to look at is those inputs, making sure that they're all going up by the same amount and that there's nothing tricky that we need to look for, which is true. All of these are going up by ones. And yes, I know it seems frivolous and stupid to write this plus 1, but this is how you show work. This is how you get away with not doing change in y over change in x 14 times. Okay, so next on to the outputs. In order to get from 4 to 7, we do adding 3. In order to get to 7 to 10, I add 3. And the reason I jumped to adding 3 and not multiplying by something was because looking at going from 4 to 7, there's not an easy number that I can multiply 4 by and turn that into 7. Is there something? Yeah, of course. But no, I don't want to figure that out. So moving onward, 7 to 10 is 3, 10 to 13, and 13 to 16 is 3. So you can see that table A is clearly the linear one because there is that constant rate of change, aka that common difference. So this is a linear because there is a common difference of plus 3. AKA, just because buzzwords are fun to use, it has that constant rate of change. AKA, that slope, which will come in handy when I'm creating the equation. So if I'm talking linear, the equation of a linear function or linear equation is that y equals mx plus b that we know and love so much. Which two pieces that we need to have filled in are the m and the b, which stand for your slope and your y-intercept. We already know that our slope is that 3. So that gives me the equation y equals 3x, and I just need to find that b, or that y-intercept. So we could do what we've been doing for a while now and pick one of those points on the table, plug in something for x and y, which I will go ahead and show really quick. I'm going to pick 1 and 10. So 10 would be equal to 3 times 1 plus b. So b plus 3 would have to be 7, which I could have also very easily figured out if I noticed that this point right here, the x is 0. This is my y-intercept, which would then tell me to just throw that plus 7 on there. So either way, if that y-intercept point doesn't jump out at you, or if, let's say you're not given that, you can still solve for it using the method that we've practiced a billion times. Okay, so looking at table B then, this one's got to be exponential. Let's just take a look, see to make sure. Going from 2 to 6, I could add 4, true, but I could also multiply by 3. And adding 4, the reason I'm not going to do that is because adding 4 is not going to get me to 18 here. 6 plus 12 would have to get me to 18, which is not a constant rate of change, so definitely not linear. But 6 times 3 gets me to 18, and 18 times 3 gets me to 54, and 54 times 3, which I'm just going to check real quick on my calculator because I like to do that, is definitely 162. So this relationship is clearly exponential, and that's because there is a common ratio, aka multiplying factor. Of 3. So not linear because it does not have a constant rate of change. No constant rate of change. That's what makes it not linear. All right, so the exponential equation is that y equals a times b to the x power, where the two pieces we're filling in here are the a and the b this time. So just like usual, we can notice that my y-intercept is right here with the 0, 2, that starting value. That's my y-intercept. So I have y equals, and for a, I put 2. And that b, that base, the number I'm raising the exponent to, that thing that I'm repeatedly multiplying by, is that multiplying factor, which in this case was 3, and my x is staying as an x. And there we go.